Hello everyone, I'm Xiao Gang. In this chapter, we'll briefly talk about logging in Unreal Engine. Because you can see how it's declared. The way it's declared is exactly the same as the declaration style of our tag. Actually, the underlying logging also uses a struct. We emphasized before that this log cannot be used outside the main thread, and that's perfectly fine. Okay, what are we going to talk about in this lesson? Let's briefly discuss debugging in Unreal Engine. Actually, Unreal Engine actually provides a large number of tools. It doesn't just give you a black box. Then you call the API. It provides the source code and the accompanying game, and the game performance development and analysis tools, all prepared for you. And as for these tools, actually, each tool could be covered in its own chapter. So what tools are there? The simplest way is, first, you watch this video. First, let's find the Unreal Engine. Then we find the user. Find the official one here. Then, in this UEFH section, that's it. Then you find it here. It's this expert sharing video. Watch this video. You can start by watching this video. That's perfectly fine. No problem. This is a companion app for it. It's probably like this, at this position, very detailed. You can take a look first. Take a look. Okay, so we won't actually follow this app or explain it to you, because the video content is the same. You can check it out yourself. We'll only talk about what I have here, what I think you need to understand at this stage. Some information you should know. For example, here, there are some performance analysis tools. Where exactly are they? It should be. Do you see this list? These things are, if you are a senior developer, you should know all of these, especially these Unreal Inside analyses. Whether it's memory, CPU, GPU, and even rendering. We'll have a chance to cover these later. If there's time, I'll explain them to you, but it's probably not something we need to do at this stage, because this stuff is actually quite a lot. We're just demonstrating the most commonly used ones. Oh, back to logging. We can put that off and talk about it later. Since this chapter mainly covers logging, let's talk about the common engine. Where might you need to debug? There are also some knowledge points. Okay, just talk about it casually on my end, and pay attention here. We often set breakpoints. This breakpoint is actually on this begin play. Here we test the brain. Regarding setting breakpoints, you can see there is an F9 here. Let's compile it, otherwise it won't break. This is a breakpoint. Then we can double click to jump to the source. Right, and here there is a Blueprint Debugger. It seems to be here. Then for example, this one. Let's tidy up the graph. There are also some settings. You can see them in the video. This Blueprint Debugger needs to be explained. You set a breakpoint. Then we start it directly here. Hey, see that? Actually, we use this often. It's actually the same as the call stack in C++. It has a call stack. Yes, blueprints can call each other. Sometimes it's blueprint, sometimes it's C++. Okay, this is a relatively simple thing. Nothing much to say. Then this is about playing Silver Day Capital, right? Then we won't talk about the keyword here. You can see, if we briefly discuss it, it might be controlled to just one small lesson. Because this is too much. Just skim through it. Okay, then if we write a 111, you'll see there's only a hello on the screen. But if we write a long, you'll see it looks like this. Okay, alright, no problem. This is just a simple demonstration. Then let's go back to our place. Actually, we have some tools here. So one very important tool should be in our, let me see. Sometimes it changes position. That's also quite normal. There is something called Widget Reflector here. This thing is very useful. You click this mouse button. You can see. You can find its underlying layout. Which location this slate is written in. For example, if we want to know about this UI, right? How it is layered, layer by layer. Right? Let's take a look. We should have another one. Let's first we set it to this button. Well, we set it, then press ESC, then cancel. You'll find that it's nested layer by layer. Then, this is one of its S buttons, but it seems we can't jump to it from here. So let's just ignore it. You can take a look through this. how this reflector is commonly used. For example, if you want to implement something in the engine, you want to write a plugin yourself and then implement this kind of saving without needing to manually edit and save or save on a timer, then you might need to know which function this button is bound to. This engine feature, often you don't know, because when you look at the engine, it's all there. It's a bloody mess. Right. So we actually have a little trick here. You see, this place is called save the create level to disk. So in the engine, we look for it like this. This is a common editor development trick. That is, you look for its comment, save the sales, the create level to disk. You can take a look. There are this many in that place. So this proves that the information we provided is not enough. Current level to disk. Let's write it again. Use current level to disk. Okay, we found it. You will see that it comes in through this place. There is a save here and then through this button. Do you see this button? And then these import call ones. Then you continue through this position. Keep searching. Check exactly which command it comes from, which command line it was registered from, these things. Then you can refer to its method to call it. Actually, the engine provides us with several common ones. This type of editor development class can help you implement asset CRUD operations, can retrieve asset metadata. It should be. Let me take a look. It should be editor. YouTube's tool panel. Let me find it for you. Actually, there are two of them. One is called Editor YouTube Library, right here. Then, why did this pop up? It has this one, right? There's this one. Then you can see there's some here. Get the currently selected asset. From the named asset, then you can generate this asset, generate some subsidiary assets next to it. Where is this kind of thing most commonly used? It is actually most commonly used, for example, in art production, when you need to batch import art assets. Then perform some art specification checks and asset validation, and establish rules for compliance and the like. It is often used in this kind of editor development workflow. Okay, we've gone off topic here. The editor is not what this course will cover. We will cover some basic knowledge of Slate so that everyone can write some. But we will not cover the editor, because the entire editor suite, there are quite a few tutorials available online that cover it. And there are some tutorials by foreigners that are also very good. If you don't know about them, I can recommend some to you. Then, in this part, we take this blueprint, and here, one detail to pay attention to. These are all based on experience. If you create a UI, then in this UI, if you set a breakpoint, it might not hit. That is to say, for example, if you set a breakpoint somewhere, even though it shows a breakpoint, sometimes it just won't hit. This is very normal. That is, setting breakpoints in this UI. This is a legacy issue. It might break. It's okay. Just don't set a breakpoint here. Add a log or something here. Right. So this is a minor issue. Okay. Then let's take a look next. Alright. Now let's look at our VS interface. VS interface. Actually, there is some VS memory usage here, but we usually don't look at this. We don't usually look at this because it's too complicated. And I've also mentioned this error list to everyone. Don't use this error list. This thing. As soon as you see my project is running, it still has so many errors, right? So don't look at this error list. We suddenly look at this build and then debug. Sometimes you will have an Unreal interaction login. These are the ones integrated by Unreal. These are relatively more valuable pieces of information, all located here. And then, one point worth noting is that actually we have a lot of these here. We have a show FP as here. Many friends often ask in the group like this. That is, they ask questions like this. You can see. I need to give a simple demonstration here. That is, take a look. That is, they can give you a screenshot like this. They ask you, Master, my computer, my scenes, this C, why is the frame rate so low? What is the cause of the bottleneck? How do you optimize it? When you ask this question, I think there's no way for the group to answer you because you only provided this one image and you only gave one frame rate. So actually, no one knows where your bottleneck is. The correct way to do it is like this. You should at least provide this, right? Then look at these parameters. You'll know roughly where the bottleneck is. Obviously, If the GM section here is red, then it's very clear that the CPU has a problem. That is, some of your code might be on the CPU. You might be generating images on the main thread, fired a lot of rays on the main thread, or read a large amount of coastal savings on the main thread, fired many rays on the main thread, things like that. All of these could potentially crash the game. And then, for the GPU, it's when the rendered scene is particularly large, or lighting and shadows are relatively complex. Then the GPU might spike into the red. As for these things, actually, in our place here, we can see there is a static command. Let's take a look. Here we write. It's hard to see. It changed recently. Actually, it's not easy to collect. This place, there is a seek command here. You can see there are also many command introductions. What each of them is used for, you can see. That's not in this lecture. Just giving you some extra information. You absolutely must not. Just take these two parameters and ask how to optimize this performance, how to analyze it. To be very honest, every piece of code you write can actually be optimized and analyzed, but if you only give this information, then we won't be able to continue discussing this issue with you. That is, even if you directly post an error list here, others still won't be able to analyze your problem and won't be able to help you. This is very troublesome. There's not much we can do either. I think this is also one of the original intentions behind me creating this course. Okay, you can see here, actually it is controlled here, and sometimes we debug the AI. You can see, right, this is it. Every single debug command in here is very important. Then there is actually something called screen percent. It has a rendering percentage. If your computer is relatively low end, you should not set that rendering percentage to 100. You set it to 50. So the load will be lighter. Actually, I don't think I explained this part. Your Blueprint teacher should probably cover it. You see here you can choose different engine skeleton settings. This will display different performance levels because my computer is a top-tier machine. So I just set everything. Usually we use Epic. The computer is barely adequate, and when you write programs, you don't really care about its rendering effects. You can set it to media or high. Like on my laptop, I often keep it on media because it's too laggy. The CPU can't handle it, and if my graphics card is relatively good, I would just select CMIC. That's it. Okay, these are some small details. Basically, for difficult projects, it's more or less the same. There's also one thing I should have emphasized to everyone. This setting is about whether you need auto when compiling, etc. Okay, then let's go back and look at our VS. This VS is very important. We need to do something like this. Let's go back here, back to our place here. In this actor, in begin play, we set a braid, should set a bat, no problem. What are we going to do? Actually, let me show you a property that is quite important. We are logging this map. You should create this yourself. We haven't written any code yet, right? So there's nothing to set up. We placed one of these in. Then here we use this. Need mode. Started in this lesson server mode. I have 1 or 2 players on lesson server. Okay, then after we enter, actually a breakpoint is hit here once. We continue. You see a breakpoint is hit again. Good, pay attention. So we mainly look at this local. You can click here. We click a local. This is something I often use inside the actor. He has something like this here. He has a remote. That is a remote character. Right. That's roughly what it means. In this place, you can see his character. That is to say, he actually has this object on the server. And this object also exists on the client. And here, we better turn on his replication. Then let's do it this way. Let's create a pointer for him. Then we put it in this position. We can open it via C++. But I might not want to click on that C++ here. Change this name. Delete this. Here, if it is here, we can find our ePolitics. At this point, let's execute it again. Note, start 2 players, 1 host, 1 client. Actually, these 2. Then here, the pin. See, the first one is the host. its local character is authoritative, and its remote character is this long. Let's go in and look down. Okay, then the second one. Second, we actually only have him. Then on the client side, his local character is known, his remote character is authoritative. That's roughly what it means. That is, sometimes we check through this variable list, this value, and then sometimes we can do this. We can take this value, that is, you can right click. Actually, you can add watch, and you can also monitor its value changes. For example, if it is a Boolean value or a frequently changing word. Sometimes when you write code, you don't know who modified this variable. You passed in 10, then after you passed it, you immediately check, it's still 10. Then suddenly, after 2 or 3 frames, you find this variable has become 8, and you can't find it no matter what, where or who modified your data. Then you can add some conditional breakpoints, or some final stater, or some watches. That is, you can always monitor this variable. If it changes, you can see it immediately. So that's roughly what VS debugging is about. It should only be used in these few places. Okay, why is there a watch point? This information, because sometimes with multi-threading, you really don't know this. The timing issue, you also don't know where it was changed. There might be some degree of variation. These issues, because it involves multi-threading, so this thing exists, you just don't know who changed your stuff. And they might even change it back. So some problems may arise in between. So specifically these options, just take a look. I just want to emphasize it for everyone. You can see this meat here. Okay, so roughly speaking, this lesson has briefly gone over these basic debugging knowledge points. And once you have mastered these, actually here, it seems I missed something here. Here you can use step into. This is step over. This is equivalent to F1 for step over. So this is one lane. To advance one line, press F10. And step into is to go inside. So it enters this function, then this state out actually comes out, and then it just jumps out directly. So one goes in and one comes out. That is a smooth step forward. And roughly speaking, more or less, I think some debugging techniques that might be needed. I've covered up to this point for everyone. Okay, then see you in the next lesson. In the next lesson, I'll start talking about this log, how we use it.